learners, welcome to another chapter to Men TV, that is mathematics, entertainment and news. How we are enjoying the videos being uploaded. Very soon we are going to upload entertainment, sports and current news updates going on all over the country and around the world. So today we are to look at fractions. So let's go to the classroom to begin with fractions, as promised in our last topic on the algebraic expressions. First lesson, we began with the introduction of fraction. Today, we are to look at ordering of a like fraction and unlike fraction. In ordering of a like fraction, we are first to define what is meant by a like fraction. A like fraction is a type of fraction that is having the same denominators but different numerators. We call it a like fraction. So in comparing a like fraction, we'll first look at whether they have the same denominators or different denominators. If the denominators are the same, we call it a like fraction. Then we'll now look at the numbers that are on top. We call it numerators. So let's look at the first example that has denominators and numerators. You will see that the numerators is going to be different, but the denominators are going to be what? The same. So let's look at the first example. So you can see that we have 13 throughout. The 13 are called denominators and the 9, 5, and 4 are called numerators. So this one is called a like fraction. A fraction having the same denominators but different numerators, we call it a like fraction. So let's order this like fraction into ascending order and also descending order, starting from the greatest to the less number, or from the less number to the greatest number. So let's look at the first one, how to arrange this fraction in descending order. How do you arrange this fraction in descending order? Before we look at the first greatest number on top, we call them numerators. So here the greatest numerator here is 9, followed by 5 and followed by 4. So let's arrange these numbers in that order. We have 9 is greater than 5, followed by 4. So this arrangement is called arranging in descending order from the greatest number to the less number. So you can see the greater than symbol is separating the fractions, making it in descending order. The next step is to arrange in ascending order, that is arranging fractions from the less number to the greatest number. So here the less number here is 4, followed by 5, followed by 9. So this arrangement is called ascending order from the less number to the greatest number. The next arrangement that we are going to look at is the same like fractions but another different example. So let's look at the next example that's on the screen there. You can see 8 running throughout. So we call it a like fractions. The 8 there are called denominators and the numbers on top are different. We call them numerators. Since the denominators are the same, we call it a like fraction. So let's arrange this like fraction in descending order first. In descending order, we will arrange from the greatest number to the less number. Here, the number that is the greatest here is 15, followed by 13, followed by 11, followed by 7, followed by 5, followed by 1. And note, we have to use the greater than symbol to arrange this arrangement in descending order. The next step we have to arrange is called ascending order. That's arranging from the less number to the greatest number. So here you can see that the less number here is 1, followed by 5, followed by 7, followed by 11, followed by 13, and followed by 15. So in arranging this ascending order, you can see that we have less than symbol running throughout. That is arranging from the less digit to the greatest digit. And in descending order, you can see the greater than symbol arranging from the greatest number to the less digits. All this arrangement, we call it descending order and ascending order of like fractions. Now, the next subtopic we have to look at is unlike fraction. In ordering of unlike fractions, the formula here is different. We have to master least common multiple. So in ordering of unlike fractions, we have to first master least common multiple since the denominators are different. So let's look at the first example. You can see that the denominators are different. That is 8 and 6. 8 and 6 here are the denominators, so they are different. Since the denominators are different, we have to apply the rule of division to find the least common multiple of 8 and 6. So the least common multiple for 8 and 6 is, so the least common multiple for 8 and 6, we have to apply the least common multiple to solve for the 8 and 6. So let's take the first one. I have 8 and 6. What number can divide the 8 and 6? That is 2. 2 can divide 8. So 8 divided by 2 give me 4. And 6 divided by 2 give me 3. So I have 4 and 3. No digit can divide 4 and 3, but a digit can divide 4. That is 2. So 4 divided by 2 give me 2. Here, 3 can divide 2. So I'll repeat my 3 down. So now I have 2 and 3 here. 2 and 3, 2 can divide itself 1. 3 also can divide itself 1. So here 2 divided by 2 is 1. I'll repeat my 3 down. The next step is to bring my 3 again. So 3 will also divide 3 one time. So if we look at this example above, you can see that the last base or the last digit for the 8 and 6 is 1 and 1. Our aim is to divide to get 1 and 1 for the base of the 8 and 6. That's the numbers that we are going to use to find the least common multiple for 8 and 6. The last digit should be 1 and 1. So now we can now multiply the 2 times 2 times 2 times 3. So multiplying 2 times 2 times 2 times 3, I'll have 24. So 24 becomes my least common multiple. Since 24 becomes my least common multiple, I will now use that rule to find my descending order and also ascending order. So first, let's find the descending order of 7 and 8 and 5 and 6. So now, we will now use our least common multiple to find both ascending and descending order. So my least common multiple here is 24. So now 8 divided by 24 is 3. Then 3 times 7 will give me 21. And 24 divided by 6 will give me 4. 4 times 5 is 20. So 21 and 20, the bigger number here is 21, followed by 20. So 21 is bigger than 21. So now, since 21 is bigger, 7 is bigger than 5. So now I'll now arrange it from the descending order first. So in arranging from descending order first, I'll have my 7 over 8 greater than 5 over 6. That is 7 over 8 greater than 5 over 6. The next step is to arrange in ascending order. That is from the less number to the greatest number. Here, the less number here is 5. So 5 will be less than 7 over 8. So here 5 is less than 7 over 8. That is arranging in ascending order of this fraction. The next example is also to continue with the unlike fractions. I said earlier, when solving unlike fractions, our aim here is to find the least common multiple of the denominators. So let's take the next one. Here I have 4, 3, and 6. The least common multiple of 4, 3, and 6, we have to apply the rule of division to find the least common multiple of these 8 and 6. So let's find the rule to find the 8 and 6. The first one, I have 4, followed by 3, followed by 6. One may ask, what digit can divide 4, 3, and 6? 2 can divide 4 and 6, so I'll begin with the 2. 2 divided by 2 give me 4, and I'll repeat my 3 down. 6 divided by 2 give me 3, so I'll repeat my 3, 3, and 2. Then I'll come to the next step. What number can divide 2, 3, and 3? I'll begin with the 2. 2 can divide 2 one time, so I have my 1 here, but 2 can divide 3, so I'll repeat my 3 down. 2 can divide 3, I'll repeat my 3 down. So I'll ask myself again, what digit can divide 3 and 3? That is 3. 3 will divide itself 1 and divide itself again 1. My aim is to have 1 throughout the base. So the bases here have 1, 1, 1 throughout. So I'll now multiply these red numbers, the numbers with the red sign, that is 2 times 2 times 3. So 2 times 2 times 3 will give me 12. So 12 is my least common multiple for 4, 3, and 6. So now let's move on to find the number that is the greatest using the least common multiple. So with my least common multiple here I have 12. 12 here is my least common multiple. So I'll pick the first one, that is 4. 4 divided by 12. 4 divided by 12, I have 3. I'll multiply the 3 times 3. Then 3 times 3 here will give me 9. Then the next one is 12 divided by 3, I have 4. 4 times 2 give me 8. The next one is 12 divided by 6, that is 2. 2 times 5 will give me 10. So 10, 8, and 9. The bigger number here is 10. So 10 will go for 5 and 6. Followed by 9. 9 will go for 3 and 4. Followed by 8. 8 will go for 2 and 3. So let's arrange it in first ascending order and descending order. So let's arrange the first one. In arranging in ascending order, we will look at the number that is the less. Here, the less number here is 2. 2 over 4. You can see that 2 over 4 has 8. So 8 is the less number here. Followed by 9. You can see 9 here has 4 over 3. And then the biggest number is 10. That has 5 over 6. So in arranging in ascending order, I will arrange from the least number to the greatest number. The descending order means that I will arrange from the greatest number to the less number. So here, the greater number here is 5 over 6, followed by 3 over 4, followed by 2 over 3. So this arrangement is called descending order with the help of the less than and greater than symbol. So here, the greater than symbol goes for the 5. So 5 is greater than 3 over 4. Then also 3 over 4 is greater than 2 over 3. So you can see the greater than symbol. This is a less than symbol. Less than symbol means that 4 is greater than 2 over 3 and 5 is greater than 4 over 3. Let's look at the next example, that is unlike fraction. I said earlier, in arranging of unlike fractions, we will first find the least common multiple. So the least common multiple for 8, 6, 4, and 5, we have to apply the division rule to solve for the denominators, because here the denominators here are different. That is 8, 6, 4, and 5. So let's apply the rule to solve for these denominators. That will help us find our least common multiple. So I have 8, 6, 4, and 5. I'll look for a degree that can divide 8, 6, and 4. But no degree can divide all of them throughout. So a degree can divide 8, 6, and 4. And that degree is 2. 8 divided by 2 give me 4. 6 divided by 2 give me 3. 4 divided by 2 give me 2. I'll repeat my 5 here because 5 cannot divide 2. You get decimals. And here we don't apply decimal. We have apply whole numbers here. There we have 4, 3, 2, and 5. I'll pick a degree that can divide 4, 3, 2, and 5. No degree can divide all of them, but 2 can divide 4 and 2. So here 4 divided by 2, I have 2. I'll repeat my 3 here, since 3 can divide 2 to get a perfect whole number. And 2 divided by 2 here, I have 1 here. Here to 5 can divide 2 to get a perfect whole number. So I'll write my 5 here, repeat my 5 here. So I have 2, 3, 1, and 5. So what degree can divide all these 4 digits? No degree can divide all these 4 digits, but they can divide themselves. So 2 divide itself 1. I'll repeat my 3 down, repeat my 1, and repeat my 5. So I have 1, 1 here. I'm left with 3 and 5. So 3 divided by 3, I have 1 here. 5 also will be repeated down. So I have 1, 1, 1 here. Then 5 will divide itself 1. So my aim is to get 1 throughout the base. Since I have 1, 1, 1 throughout the base, I'll multiply the numbers with the red symbol. So I'll multiply 2 times 2 times 2 times 3 times 5. That'll give me 120. So 120 is my least common multiple. So I will now use my least common multiple to find these unlike fractions, and after that I will arrange from the greatest number to the highest number, or from the least number to the greatest number. So here, the first one, I'm to apply 120. So here, 120 divided by 8, that will give me 15. 15 times 5 give me 75. Then 120 divided by 6 will give me 20. 20 times 5 give me 100. Then 120 divided by 4 will give me 30. 30 times 7 will give me 210. And the next one is 120 divided by 5, that will give me 24. 24 times 3 will give me 72. So I can now arrange this my work in either ascending order or descending order, depending on our choice. So here, our choice here is to arrange it from either ascending order or descending order. They'll all be marked correct. So let's look at the first one. The first one is 75. 75 goes for 5 over 8. 100 goes for 5 over 6. 210 goes for 7 over 4, and 72 goes for 3 over 5. So if you look at this arrangement, one may ask, are they in ascending or descending order? Now 7 over 4 goes for 210. So this arrangement is called descending order. Descending order means that you are arranging from the greatest number to the least number. So the greatest number here is 210. That goes in for 7 over 4. The next greater number here is 100, and 100 goes in for 5 over 6. The next one is 75, and 75 goes in for 3 over 5. So this arrangement is called descending order. From the greatest number to the least number is called descending order. The next one is to arrange in ascending order. That is from the less number to the greatest number. When you look at the example here, the less digit here is 72. And 72 goes in for 3 over 5. And the next less digit is 75. That goes in for 5 over 8. Followed by 100. That goes in for 5 over 6. And the greatest number here is 210. That goes in for 7 over 4. So this arrangement is called descending order. It's called ascending order, from the less digit to the greatest digit. So ascending order means that arranging numbers from the less number to the greatest number with the use of the less than symbol. You can see the less than symbol throughout. So this is called ascending order, and this is called descending order. So learners, I hope it was well understood. I'll give some work to be tried. This work will be solved in our previous exercise and also our previous example. So watch out to look at another interesting topic on fraction. That will be our next lesson. And before we start that next lesson, this trial work will be solved before that next lesson will be. So bye for now, and thanks for watching.